Hello and welcome to the last video on chapter 2.1 from the Statistics Unlocking the Power of Data by the 5 Locke authors. And I'm just going to go through one more example in this chapter where we're looking at 1 and 2 categorical variables. And this one involves vitamin D injections. So many kidney dialysis patients get vitamin D injections to correct for lack of calcium. And there's two forms of vitamin D injections are used, calcitriol and paracalcitol. The records of 67,000 dialysis patients were examined. It's a very large data set. Half received one drug and half received the other. So split in half between these two vitamin D options. After 3 years, about 58.7% of those getting paracalcitol had survived, while only about 51.5% of those getting calcitriol had survived. So what I want to do, and I'm going to do this on a separate document, construct an approximate two-way table of the data. And these percentages aren't exact. We need more decimals here, so we're going to have to do some rounding. And just to note, this data comes from a study that was published in 2003 in the New England Journal of Medicine, linked here at the bottom. Okay, so I want to go to a Word document where I kind of just wrote up the copy and paste the exact same information over. So I want to note I have two variables here. One is what drug they used. Drug used. And the other variable is survive. Or died. So one variable I think about, I'm going to make one of these a row vector and one of them a column vector. And each of these, I have two options. I have the two different drugs used and the survive or not. So I'm going to create a table inside here. And I would need 2 by 2 to just show the variables. But what I want to do is I want to make this a 4 by 4. You can see here, because I want to make a total column total row at the bottom, so a grand total. And now here I need to put two variables as the columns. You could do either one. I'll use survived and died, is what I have in the slides. But you could put the survived and died as your rows instead of columns. And then I'm going to put the calcitriol as one variable and the paracalcitol as another column variable. All right, now I need to kind of get this information into the table. We're given the grand total is the 67,000. And we're also given that exactly half received each of the two drugs. So if I divide the 67,000 in half, I get 33,500. So that's going to be the total for both of these. Now I need to look at this number, the 57.5%. That's the survival rate of those getting the paracalcitol. So in this cell right here, what I need to do is calculate, you can do this on the side of the cell, but I'm going to do it in the cell right now so you can see. 58.7%, I need to turn that into a decimal, and now I'm going to multiply that by the 33,500. And if you throw that in your calculator, 0.587 times 33,500, we get a decimal. So it's kind of annoying, but we don't have exact information here. That 0.5, we're going to round that to 19,665. So here we got the value in this, and all you really need to add in the square is the total number. Better. So that's all I need, just showing the work right here. And if we know it's about 19,665 survived, and the total is 33,000, all I need to do for this next cell is to take 33,500 and subtract the amount that survived, 19,665. Put that in your calculator. And we get this to be about 13,835. again, filling out the table, all you need is this information right here. So we do the same thing here at the next percentage, 51.5% of those getting calcitriol survived. So that's going to be the cell above. Go through the same analysis, that's 0.515 times 32,500. And that's going to be equal to 17,252.5. But we're going to round that, unless we have more information, to 17,253. And we do the same thing over here, subtract this, 32,500 minus 17,253 to get the total number that died. And that's going to be about 16,247. And again, really when you fill in this table, you just want to include what I'm highlighting in here. You don't need to show the work. I just want to go through once to show you how to create a two-way table with information like this. So here on the slides, I've looked at kind of 67,000, cut that in half because we're given that information, and then calculating the percentages as we went through before. And then the totals down here, if I want a total, I would add these together. 36,917 survived. 30,083 had died from this study. All right, the quick summary for two categorical variables. For summary statistics, we're going to look at two-way tables, also difference in proportions. For visualization, I would throw the two-way table as part of that visualization to visualize the data, but we're also looking for charts side-by-side bar chart. I think this should be used more often, but occasionally you might see a segmented bar chart as well. Okay, that finishes chapter 2.1.